Welcome to Summarize Science, where today we are looking at a new way to turn flat photos into stable 3D worlds. Converting a single image into a 3D scene is a major goal for creators, but it is much harder than it seems. The paper we are discussing introduces REST3D, which stands for Reconstructing Physically Stable 3D Scenes. Usually, when AI tries to do this, the results are physically impossible. Objects might float in midair or pass right through each other, causing the whole scene to explode when imported into a simulator. This is a big problem for developers who want to use AI to generate digital assets for games or movies. To fix this, the researchers developed REST3D, a framework that prioritizes physical stability from the very start. The first step involves an agentic system that identifies every object in the photo and figures out their relationships. It uses a vision language model to look at the image just like a human would to understand the layout. For example, it needs to know that a potted plant is sitting on a table and that the table is supported by the floor. This hierarchical understanding is what the researchers call a scene tree representation. This creates a blueprint for how the 3D world should be structured based on gravity. Next, the system performs canonicalization, which is a fancy word for making sure the whole scene is aligned correctly with the ground. This stage ensures that the floor is actually flat and that gravity pulls objects in the right direction. But even then, some objects might still be slightly stuck inside one another or slightly off balance. This is where the physics-constrained optimization comes in. The system actually runs thousands of tiny simulations in the background to find the best possible placement for every item. It uses a technique called the cross-entropy method to iteratively improve the layout until it is stable. It specifically looks for the elite layout where objects have the lowest velocity energy. This ensures that the digital world behaves just like the real world would without objects shaking or drifting. When compared to other state-of-the-art methods, REST3D achieves a massive 83% improvement in stability. You can see in Table 1 how the failure rate drops significantly compared to previous attempts. Figure 3 shows a side-by-side comparison of different AI models trying to simulate the same room. While other models see their chairs and tables fly apart, the REST3D scenes remained perfectly still. It is a striking visual difference that proves the importance of physics-aware AI. One of the most exciting parts of this research is the potential for virtual reality. The researchers demonstrated a system where a user can wear a VR headset and interact with objects from a photo in real time. Because the physics are pre-stabilized, you can pick up a virtual cup or move a chair without the world glitching out. This could revolutionize how we build digital twins of our own homes or create interactive gaming environments. To recap, the researchers solved the problem of exploding 3D scenes by teaching AI to understand support and gravity. They used a physics simulator to test and refine the scene until it was perfect. This three-stage process ensures that the result is both visually accurate and physically plausible. In the future, this could mean that anyone can take a quick picture with their phone and turn it into a high-quality video game level. It represents a huge step toward bridging the gap between our physical world and the digital one. Thanks for watching Summarize Science.